Okay, here we go. Unit 5, lesson 9. Video of the weekend was the man versus machine video on YouTube. We got like 74 inches, so what was that? A little over 6 feet at my house this weekend. The resort's got like 8 to 9 feet. Sunday at Heavenly, Sunday afternoon, was some of the most unreal snowboarding I've ever been in. But anyway, I did a pretty fun little video. Check it out sometime. It's called Man versus Machine. But let's just jump right into the questions. So lesson 9 starts with 9.1 cylinder volumes. So I'm gonna go up to the front and here we go. Okay, so here are two solids. So this is a cylinder and this is a prism. So we got a cylinder versus a prism, right? What information would you need to calculate the volume of each solid? I'll tell you, on the cylinder, you need the radius and the height. So for cylinder, you need the radius and the height. For the prism, and you should already know this, but you need the length, the width, and the height. So you need the height, the length, and the width. Why? Well, because here's your formula for volume. For a cylinder, it's pi r squared times height. And for the prism, it's length times width times height. Okay, what is the same and different about how you would find the volume of each solid? So the first thing that jumps out to me is they both have height. So the same, they both include the height in the volume formula. So there's height in the volume formula. How are they different? Well, the cylinder is pi r squared times height, and the prism is length times width times height. So for the cylinder, it's pi r squared times height. For the prism, it's length times width times height. Now what's cool is that length times width is the base's area. Pi r squared is the circle's area, or the base. So in both of these, it's base, area of the base, times the height. So that's another thing you could say. For both, it's volume equals base times height. That's the first one. Okay, the water container. This is a cool problem. All right. Cylinder. Prism. So, suppose the prism contains water that reaches a height of 1 centimeter. So if this is 10, the water is just like right here. So there's your water. Okay. Draw a representation of this situation. Once you label it 1, you're good. Okay, now the water is poured from the prism into the cylinder. What is the height of the water in the cylinder? What is the height of the water in the cylinder? Well, let's dissect this circle right here. The area is pi r squared. Okay, so the area is pi 6 squared, so the area is 36 pi. Now let's look at this base right here. You got 9 and 4 pi. So the area of this is 9 times 4 pi. So the area of the prism base is 36 pi also. So they have the same base, the same area of the base. They also have the same height. So if the area of the bases are the same and the height's the same, and we pour this water into here, well, this water is going to be right here. And it's also going to be at a height of 1. So what is the height of the water in the cylinder? It's 1 centimeter. Why? The areas of the bases are the same. And the height is 10 for both. So because the areas of the base are the same and the height is the same, the water is going to be 1 for both. Okay, number 2. Suppose the prism, let me erase. So suppose the prism contained water that reached a height of 3. So you got water up to here. Now, it's 3 centimeters high instead of 1. If the water were poured into the empty cylinder, what would the height of the water in the cylinder be? Oh, pretty easy. Still be 3. Because the same exact answer. The areas of the bases are the same and the height is 10 for both. So it's going to be the same height. Just think of like it's coming up in a future problem, but just think of like aquariums. So you see aquariums in this shape a lot of the time. They could also be in a cylindrical shape too. So anyway, that problem is coming up. I think the answer is 41 fish, if I remember correctly, but we'll get there when we get there. Okay, that was the second problem. Okay, revisiting rotation. Suppose each 2-dimensional figure is rotated around the vertical axis shown. Each small square in the grid represents 1 square centimeter. So for each solid, sketch or describe in words the 3D solid that would form. Okay, Let's see. The first one is going to be 2 cylinders on top of one another. Can you see how that would be like 2 cylinders on top of one another? The second one is going to be like a toilet paper roll with like a missing area in between. So, the first sketch, you're going to have a cylinder on top of another cylinder. So it's going to be something like that. The second one you will have something like this, except from here to here is going to be missing. So you're going to have like a middle spot that's like missing. So, sketch or describe. So sketches are there and there. Describing words. 2 cylinders on top of one another. Resembles a 2-story wedding cake. A 2-story wedding cake. Imagine a bride and groom up top. Second one is a cylinder, but missing or hollow middle point. The middle section, you could call it. Resembles a toilet paper roll. Okay, so the first one looks like a wedding cake. The second one looks like a toilet paper roll. All right, find the solids volumes. So this one is going to be 1 plus 2. So 1 plus 2. Let's look at 1. Your radius is right here, which is 2, and your height is 3. So for 1, it's going to be pi 2 squared times 3 plus your radius is 5 and the height is 3. So pi 5 squared times 3. It's going to be the first volume plus the second volume. It's pretty easy. 2 times 2 is 4, times 3 is 12, pi plus 5 times 5 squared is 25, times 3 is 75. 75, so 87 pi. And we're talking volumes, so you gotta say centimeters cubed. That's the first one. The second one's a little tricky, but it's not that hard. You gotta find first the radius equals 5. So we're gonna do the big minus the small. So the big one is 1, 2, 3, 4, 5, 6 for the height. radius of 5, so it's going to be pi 5 squared times 6 minus, we don't know yet. Well, I'll just do it right now. The only difference is the radius of the missing portion will be 3. Height will still be 6. So minus pi, radius of 3, height of 6. So big minus the small, so we're almost there. 5 times 5 is 25 times 6 is 150 pi. So 150 pi minus 3 times 3 is 9 times 6 is 54. Don't forget the pi. So 54 pi. 150 pi minus 54 pi is 96 pi. Now we're talking volume. You gotta say centimeters cubed. So the first one is 87 pi centimeters cubed. The second one is 96 pi cubic centimeters. Second problem done. No, third problem done. We're done. Sweet. All right, let me go over the summary. Let's just read it. I'll try to put it in my own words. Okay, here we go. The Warriors are gonna make the playoffs. I think they'll be the 7 or 8 seed, but they gotta catch a couple teams here. But anyway, cylinder and prism volumes can be found by multiplying the area of the figure's base by its height. The formula volume equals base height, where V represents volume, B is the area of the base, and H is height, captures this concept. Consider the solid form by rotating this rectangle around the horizontal axis shown. The result is a hollow cylinder of height 5 with inner radius 1 and outer radius 4. So yeah, you gotta find the area of the circular base. And then you gotta find the inner cylinder, and then take the big one minus the small. So that is lesson 9. Go Warriors. And just remember, focus, grind, hustle, execute. All right, have a good one.